When you are done with this lesson, you should be able to change fractional exponents into radicals and radicals into fractional exponents, apply all the exponent properties to a variety of problems. And again, this lesson is fractional exponents extension. Fractional exponents play the same rules or properties as all other exponents. It is, in fact, these properties that can justify many standard manipulations with square roots and others. For example, simplifying roots. Remember, you can use your calculator's prime factorization button to help you simplify the numbers or coefficients in radical exercises. So we only consider a square root simplified when all of its perfect square factors have had their square roots evaluated. If they aren't perfect squares, they remain under the radical. So we're going to rewrite 180 in factored form. So on your calculator, on a calculator page, do your menu number factor of 180, and you should get 2 squared times 3 squared times 5. Now remember, 2 squared is 4. 3 squared is 9 times 5. Now these are perfect squares. So anything to the power of 2 is a perfect square. And since we're taking square roots out, that's important because the square root of 4 is 2. The square root of 9, so times, is 3. And the square root of 5, I don't know. It's irrational. So anything I bring out front, I'm multiplying. So that's why 2 times 3 is being multiplying. So that's 6 times the square root of 5. Now I could have also, way over here in this problem, 4 times 9 is 36. So I could have had 36 times 5. Some of you also learn to do 2 times 2 times 3 times 3 times 5. And we take out pairs because it's a square root or an index of 2. So we take out pairs. However you do it, you need to do it correctly. So let's look at exercise 2 where there's some variables in these problems also. So again, all 3 of these exercises are square roots. So we're taking out groups of 2 or perfect squares. So go ahead and break down 18. So 18, if you're using your menu number factor, is 2 times 3 squared. Well, 3 squared is 9, so 2 times 9. The square root of 9, it's a perfect square, it's 3. So I have 3 square root of 2. Now x to the 4th is 4x's. My index is 2, so I'm taking out pairs. Another way is to say if I have x to the 4th, how many pairs are in 4x's? And your answer should be 2 of them. So my answer is 3x squared times the square root of 2. In the next one, 200. So why don't you go ahead and pause the video and break down all these numbers, and if you're confident in the letters, go ahead and try it. Hopefully you've started the video back up and your answers match what I got. And I forgot the radical 2 on that one. And again, these are the types of questions, these are expressions, so you could store for your values, store for your variables, and then plug in the expression and plug in your answer, and they should match. Okay. All right, on the next page, we can extend the simplifying process to include cube roots and higher order roots by simply extending our thinking. Remember, we only consider a root simplified when all of its perfect factors have had their roots evaluated. If they aren't perfect, they remain under the radical. So now we're going to look at roots of 3, roots of 4, roots of 5, and that means that's the groups that we take out, or the perfect factors. So if I do the perfect factors, of 16, I have 2 to the 4th. And please do not forget your index. So that means I have 2 to the 3rd, which is 8, times 2, and that's a cube root. Well, the cube root of 8 is 2. Cube root of 2. Are you okay with that? So remember, there's 4 2's in here. I took out a group of 3. That's how I got that 2, and that stays inside. So 108 is cube root of 2 to the 2nd times 3 to the 3rd. So these match, and you can kind of think of these also as they undo each other. So I know that the cube root of 3 to the 3rd, they cancel. So I have 3, and then I have 2 squared, which is 4, inside, and it's a cube root. Shouldn't have left such a big space, but I did. So my answer to the cube root of 108 is 3 times the cube root of 4, and I can't take the cube root of 4. How about 1,512? When I break that down, I get 2 to the 3rd times 3 to the 3rd times 7. So again, 3 and 3, those cancel each other, so I have a 2 and a 3 that come out front, which is a 6, with the cube root of 7. Okay, so you kind of use your power rules in this also. Hopefully you're getting away from having to draw them out and do all the circles. That's our goal here. If you still have to do that, that's okay, as long as you get the right answer. So now we're going to do 128, and this time we have variables in here, so we have to contend with those. Well, 128 is 2 to the 7th, so that means I have 2 to the 3rd and 2 to the 3rd and 2. And then I have x to the 8th. Well, how many groups of 3 are in x to the 8th? Well, there's an x to the 3rd and an x to the 3rd, which makes 6, and then I have an x to the 2nd. So I have a 2, which is 4, x and x, which is x squared, and then I have the cube root of 2x squared. That makes no sense to you. Then I have 1, 2, 3, 4, 5, 6, 7. I need a group of 2's, and I need 3 in that group because the index is 3, and a group of 3, so 2 times 2 is 4. For x to the 8th, I need a group of 3 and a group of 3, 2 left over inside, and then this 2 also stays inside. Okay? Practice if you are struggling with this. Ask in class. If you need to just do more, then let's just do more. So now we're going to do 4th and 5th roots. So that means we need groups of 4 or 5. So that index tells us how many in the group. So if I break down or prime factor 162, I get 2 times 3 to the 4th. They match. So I just have a 3 out front with the 4th root of 2. And that means I have one group of 3 4's. No, 4 3's. Alright, 16. That is 2 to the 4th. So 2 to the 4th. And then x to the 7th would be x to the 4th times x to the 3rd, because I add those exponents. So I have a 2x with the 4th root of x to the 3rd. And 48, when I prime factor, 2 to the 4th. So I have 2 to the 4th times 3. I have x to the 4th and x to the 4th, which is 8 of them, and then x squared. I have y to the 4th and then y. Holy cow. So which ones are to the 4th? So that means I have a 2 out front, I have 2 x's out front, and a y out front. Inside, I have a 3 left, I have x squared left, and I have y left. Oh, that one was crazy. And the last one, 64, is 2 to the 6th Oh, this time we're doing a fifth root. So 2 to the 6th is 2 to the 5th times 2. The first if you want. Then I have x to the 5th times x to the 5th times x to the 2nd. Y to the 5th, y to the 5th, and y to the 5th. So this one comes out front, this one, this one, this one, this one, this one. So I have 2 x squared y to the 3rd, fifth root of 2x squared. All right. Hope you did okay with that. I'm sorry the screen cut in front. Good luck. And if you have any questions, ask in class.